Hello. Today we're going to look at statistical inference. Now, statistical inference provides methods for drawing conclusions about a population from sample data. So say we take a sample. We want to take that sample and see what it says about a bigger population. When we talk about inferential statistics, those are statistics like a mean or a proportion that's taken from a sample and that is used to explain something bigger than just what that sample is. Now, when we do statistical inference, we'll do a significance test. A significance test is a formal procedure for comparing observed data with a hypothesis whose truth we want to assess. It's kind of like writing up a lab note on a lab report for statistics. Now, when we do this, we have a couple goals. Our goal is to check and see if some change is statistically significant. And that whether or not that's significant is whether tells us whether or not we can answer the research question involved. For instance, say I decide to make shorter videos for my AP statistics course, and I wanted to see if that led to higher grades. So I go through and I make all the videos. Students learn on the videos, and then I want to check to see if there's an improvement. If there's a little bit of improvement, we want to know if that's a statistically significant improvement or not. So the goal of this test is to be able to do that. Here is a full example. This is a paramedical. It says several cities have begun to monitor paramedic response times. In one city, the mean response time to all accidents involving life-threatening injuries last year had a mean of 6.7 minutes with a standard deviation of 2 minutes. The city manager shares this information with the emergency personnel and encourages them to do better next year. At the end of the following year, the city manager selects a simple random sample of 400 calls involving life-threatening injuries and examines the response time. He found that the mean, which is an X bar, is 6.48 minutes. Does that give us evidence that the times were improved? Well, let's take a look. Now, if we want to make a normal distribution out of this, it will be centered at 6.7 because we'll start this by assuming that they were not improved at all. So if by chance the mean was 6.7, how often would we get a value of like 6.48 if the mean was truly 6.7? Well, that would depend on the standard deviation, which would be 2 over the square root of 400 since it's a sampling distribution. And then when you put this on here, it looks like it won't happen very often. So just by looking at this, we can say it seems fairly rare that this occurs. Now, to write up a formal significance test, we do something like this. First, we start with our hypotheses, where we'll explain this in another video, but we, we, we have a null hypothesis and alternative hypothesis. And then we set up the conditions that we use to make our probability, and we need to check to make sure all those conditions are true. And then we go through and we find a probability, this much like what we did last chapter. And then when we're done, then we interpret the value that we got within the context of the problem. All right, well, hopefully we can move on to actually doing